Problem 1.1, we're going to take these different images that have been given to us and we're going to find all the lines of symmetry, for each design, for each figure. And so when finding lines of symmetry, in this case we're looking for reflection symmetry in these images. And so if we're trying to find reflection symmetry, then we should be looking for reflections. Now I'm going to try and see if I can do this with a mirror. I have a mirror here and I can see if I can get it at the right angle. If I set it on here, you can kind of see there's a lot of glare, but the reflection of the image, and it looks as if the image continues to appear just as it is. And so one of the ways to find reflection symmetry is to actually find a reflection and to take the shape and just see if you hold a mirror to it, if you can see the rest of the image reflected somewhere, and that can kind of give you points of reflection symmetry. So if you look at this first image, really it reflects on itself. I could take the two sides and just fold them in to the center right onto itself, and so what I'm trying to find is that center point right here. And so a line of symmetry in this first image would be right down the middle like this. Most of the time reflection symmetry lines are somewhere in the middle of an image, where if I take it here and fold it over onto itself, that's the line of reflection symmetry. Sometimes there's one line, sometimes there's more than one line. If I could fold it together like this, or if I could fold it the other way, and you can see this one doesn't have reflection symmetry the other way, because if I hold my mirror up this way, I don't get the top part of that image in my mirror. It disappears, and so it only has reflection symmetry one direction. So for A, that's the only line of symmetry that I can draw. For B, image B, see that image B, zoom in a little bit closer here and see if we can make that show up a little better. So in image B, it looks like if I take my mirror and put it in the middle here, you can see how the image, there it is, reflects on itself, and back the other direction. So right there in the middle, right down the center of this one, there's a line of reflection symmetry right down the middle. So right in the middle of this center object this way. So image B has a reflection line of symmetry right down the center. Now it's also interesting if I take the mirror and put it the other direction, I can get it to do this, see that the image, see there's the image and there's its reflection. So it also has another line of symmetry the opposite direction. If I can get this in just the right spot, I'm not quite getting it in the middle. There it goes. So now you can see that the image itself reflects back on itself in two directions, not only down the center vertically, but down the center horizontally. So this one actually has two lines of symmetry, one in this direction and one up and down and one left to right. So it actually has two separate lines of symmetry for image B. So the first one only had one line of symmetry, reflection symmetry. The second one has two lines of reflection symmetry for B. And then now let's look at image C. Let's see if we can find with that one. How many lines, zoom way in on this one here. How many lines of symmetry does this image have? So if I, again, take my mirror and start just looking for places like, can I reflect it back on itself this way? So do I get the same image left to right if I put the mirror in the center? And it looks like, sure enough, there's a line of symmetry right down the middle. I'm going to use a different color pen for this one, see if it shows up a little better. Right down the center, there's a line of symmetry right there, top and bottom. And then the question is, can I do the same thing the other direction? Does the top and bottom reflect? So if I see the image there, pull it away, do I still have the same image top to bottom? And it looks like This one also has a second line of symmetry this direction, horizontally. So I have a horizontal line of symmetry, I have a vertical line of symmetry. Now here's a question. Let's see if this makes sense. If I took the mirror and went angle side to side like this, let's see if I can get this one to show up. Do I have another line of symmetry there? So if I put that in there and then I pull it away, does it look exactly the same as the image that I started with? So could I put a line of symmetry from corner to corner, diagonally across this shape? Pull it away again and see if, what do you think? Think that that's a line of symmetry or not? Now here's kind of the clue. See the green triangles in the corner here? A green triangle there. And when I pull this away, it's a purple triangle here. And so that creates a bit of a problem, because if I'm going to have symmetry, reflection symmetry, I have to have an exact image. And so the green triangle and the purple triangle face different directions. And so I don't have a line of symmetry that way, even though it looks like I might have one there. There's no line of symmetry in that direction. So I still just have the vertical line of symmetry and a horizontal line of symmetry for image C. It's only two lines of symmetry. And that's it for C. Now, moving on to image D. Image D is interesting because it looks like there's lots of symmetry and lots of things that could reflect, but the question is there any place that I could put this mirror and create a reflection that's an exact copy of what I have? So let me just try it there and see what I get some interesting looking things here. So now I have, looks like I have feet and feet. If I do that, let me go the other way. If I try to do it there, then I have the head and the head. See if I can get one this way. Sure. That creates a really interesting reflection. Not quite. Doesn't give me nice symmetry, reflection symmetry from the original image, because I don't end up with what I started with. And same thing in this direction. I get some interesting images, but they're not reflection symmetry of the original image. And so this particular image has no reflection symmetry, no lines, so no reflection symmetry on image D. Even though it looks symmetrical and looks like it should have some symmetry to it, this one does not. There are no images or no reflected symmetry images. And so that's all I can do for that one. So sometimes we have one line of symmetry. Sometimes we can have two lines of symmetry, as in images B and C. And then sometimes there are no lines of symmetry. So let's continue on to E. We have four more images here we're going to do in investigation 1. In image E, we have just a standard rectangle, and I think maybe you can see that standard rectangle, we have a line of symmetry. I'm going to just kind of take my mirror and see if I can find all the lines of symmetry. There's one down the center horizontally, and I think we should have one down the center vertically. And so I'm going to go ahead and put those two in. So if I have one down the center here, I have another one down the center vertically. So I have two lines of symmetry on that rectangle. Now the other question is, could I do one this way? Do I get a line of symmetry if I go diagonally? And the answer there is no, I don't get a reflection there, which means I probably won't get a reflection here as well. So no reflection symmetry on the diagonal. So those are the only two lines of symmetry for that image E. So it appears that lines of symmetry are not necessarily all that simple to find. So we're moving on to F, continuing to find lines of symmetry. Let's see what we can do with this one. Are there any lines of symmetry for this? Let's see if I go from diagonal to diagonal. I don't get a reflected image. Diagonal to diagonal. Again, no reflected image. What if I go down the center? Do I get a exact? Still no reflected image. And what if I go? Is there a way I can go another way? Top to bottom. No reflected image. And so in the case of this parallelogram has no reflection symmetry. No reflection symmetry. Cannot find a line of symmetry where I get a reflected image on F. Let's try G. We got an equilateral triangle. Now it seems like an equilateral triangle. I ought to be able to get some lines of symmetry. So let's see what we can do here. So if I go right down the center, looks like I get my triangle back. So one right down the center. So let's put that one in. So it can reflect over. The left piece reflects directly over to the right piece. They're identical. And let's see, how about from one point to another there? Yep, I get my triangle back again. So it looks like if I do one from each vertex to a midpoint on the other side. So I think I have 3 lines of reflection symmetry for this triangle. So I don't think I can do top to bottom. I get a kind of a weird shape if I do that. So it looks like those are the only lines of symmetry. If I put my mirror right on each of those lines I made, you can see I get my triangles back each time. And so those are the 3 lines of symmetry, reflection symmetry for image G. Now you'd think that image H might give us the same result. So let's see what we can do. If I take image H and I put my mirror down the center, image H, looks like I get my triangle back. There's my original triangle. It's with the mirror. So in image H, I have a line of symmetry down the middle. There. Now on the equilateral triangle, I had one from each vertex, but let's see if I can find what happens here. If I take this, do I get my triangle back? It's really hard to see this one. It's not looking like the original. It looks like when I put it there, can't find a spot. Kind of moves around with the mirror. You can see how the triangle's changing shape, but it's not going back to the shape, the original shape, until I get the mirror completely out of the way. And so it looks like this particular triangle only has the one, so it gets close, but not quite the right shape. So it keeps kind of bending. So the only line of reflection symmetry, you can see as I move the mirror around the shape, the only time I get the image back is when I'm on the original line. I get my original triangle back. If I can get this lined up just right, there we go. You can see the original triangle reflected on itself from the original image. So only one line of symmetry. So again, we have cases where we have 1 line of symmetry, 3 lines of reflection symmetry, 2 lines of reflection symmetry, or no lines of reflection symmetry. So we have 1, 2, 3, and 0 lines of reflection symmetry, depending upon the shape. You can have none, 1, 2, 3, and even more and more. As you see other examples, you'll see where you can have certain shapes that have an infinite number of lines of symmetry. And so that ends problem 1.1.